Ladies and gentlemen, Skyline Architects is a design consultancy with many years of experience in large-scale public projects and high-rise buildings, ranging from residential and hotel developments to medical complexes and urban infrastructure. On behalf of Skyline Architects today, it is my honour to introduce architect Tran Ming Nia, Deputy Director of Skyline Architecture Joint Stock Company. As an architect with over 20 years of hands-on experience in the profession, he has participated in and led the design of many large-scale award-winning projects. Among these are projects that have become urban landmarks, such as Lamvian Square in Dalat, as well as large-scale public housing and hotel developments across the country, including the Sentosa Sky Park apartment complex and Haijung International Hospital with 1,500 beds. And now, may I respectfully invite architect Tran Ming Nia to come up and share in our first session. Session 1, Applying SketchUp in Large-Scale Real-World Projects. We respectfully invite you to the stage.
I would like to express my sincere thanks to everyone who's joining us here in person today, as well as to those of you who are currently following the programme online. I'm Nia, and today I'll be presenting on mastering the workflow from concept to construction in large-scale projects. It's also worth mentioning that large-scale projects are quite different from smaller residential works, such as houses or villas. One of the main characteristics I've noticed is that, firstly, these projects usually last around 1 or 2 years, or sometimes even longer. Therefore, when it comes to information management and handling all the inputs, we have to manage all the data extremely carefully. Secondly, these are projects that require multidisciplinary and multi-departmental coordination. In fact, we need to have an organised and administrative system in place to coordinate the departments effectively. Thirdly, the scale of these projects is absolutely massive. There can be several hundred rooms, and the number of details involved can reach into the thousands. So it's simply not possible to draw each and every single one individually. We need to find a way of working that is truly efficient. And fourthly, with large projects, we have to divide the work among several staff members. We also need to split the project into smaller files for easier management. When the workload is shared among many people, we must have a system for sharing information so that everyone's kept in the loop. For smaller projects, it might be possible for one person to handle everything from start to finish, so they have a complete grasp of the project and it's not an issue. Right. The first 2 words I want to mention are, in fact, what I consider to be a kind of yardstick for the health of the company and our system. For many companies, each deadline is almost like a haunting presence. People have to work overtime constantly, switching on and off just to meet the deadline. And I've worked in about 3 different systems. Now, deadlines are no longer a source of anxiety and have become much more manageable. So, I'm here to share about the working methods, the workflow, and how to manage our work so that deadlines are no longer a nightmare for our business. So, I should also add that today I'm here simply to share my experiences, not to criticise or promote any particular software. This is just my honest experience. If there are drawbacks, I'll mention them, because these are things I've actually been through. First, I'll talk about the 2D system, which is something that almost is so widespread, and previously it seemed there was no software that could replace AutoCAD. And even now, a lot of people still use AutoCAD to produce 2D drawing systems. But with 2D, there are certain issues that simply can't be overcome. Firstly, the drawings don't always match up with each other. If you follow a process to complete the documents from A to Z, after doing the floor plan and then the elevations and sections, the likelihood of everything matching up is quite high. However, when it comes to making revisions, it seems that information gets lost here and there. Some parts aren't updated in time, everything becomes a bit of a mess, and you can no longer keep track of whether the drawings are consistent with each other. The second issue is that conflicts and errors are often detected quite late. When working in 2D, you can't really see things clearly, and many issues are actually quite basic. But it's only when construction starts that you realise, for example, this concrete block is clearly sticking out. And having to demolish a concrete block like that is extremely costly and affects both the quality of the design and the reputation of the design consultancy. The third issue is that it wastes a load of time. When coordinating between disciplines, for example, the MEP team might ask what the elevation at that spot is. Then the architect will cut a section through that area. They'll gather all the documents related to structure, M&E, or any other relevant disciplines to create a section through that point. Then once it's sent to the relevant discipline, they can determine how their system will run through there. Previously, our team used this system. Why isn't this playing? Actually, it is that specific video clip. For example, previously in our team, even just for the ground floor plan, we had to create loads of sections for coordination. And the problem with this is that if the structural team changes the beam dimensions, updating everything is absolutely exhausting, and you can never manage to update it all. This leads to situations where, even though something is shown here, it might not actually be correct. A lot of effort goes into this, but if a project drags on and there are lots of revisions, it almost becomes pointless. Fourthly, with 2D drawings, when you look at them, they all seem perfect. Everything is presented as if it is perfect on its own, but it doesn't actually match up with the other drawings. It's very difficult for the person in charge to check those things. And when partners and investors look at the 2D drawings, they can't really visualise the space. With a construction design dossier containing hundreds of drawings, people have to go through each one individually to try and imagine what the final product will look like. Those are the issues with this 2D system. What's the drawback? And after that, I moved to a foreign company, and that's when Revit was introduced. At that time, Revit was introduced with a whole host of extremely useful features. When drawing walls, you just need to draw, and it already has the brick layer and the plaster layer. With AutoCAD, you have to offset and go through quite a few steps. The walls automatically connect with each other, so you don't need to use the trim command, and when you draw the floor plan, using the cut line immediately gives you the section, detects clashes, and everything else. I found that this was clearly like a saviour compared to the system I was using. Really impressive. But around that time, the company required us to use Revit, and there was even a dedicated BIM team on standby to resolve any Revit-related issues for all departments. So it seemed that all the conditions were fully met. There was nothing left to discuss. But after 2 years, I realised that it actually wasn't effective at all. And in fact, it became an obstacle rather than being as effective as the features I had hoped for. So, what were the barriers that I noticed? The first is the method of defining everything beforehand and then drawing afterwards. With Revit, you have to define what type of wall it is first, how thick the brickwork and plaster layers are, what the wall family is, and only then do you start drawing. When drawing any object, you have to specify whether it's concrete, brickwork or someone else, so you draw it according to the correct system for the software to understand. There are so many things like that. When you're focusing on the concept, but constantly having to deal with technical issues, your train of thought gets interrupted, and it's not effective for conceptual work. Secondly, the user interface of Revit relies quite heavily on working with tables. I'm drawing in 3D, but I have to keep ticking boxes, entering numbers, and selecting this and that for the 3D model to update accordingly. It's just not intuitive. I'm drawing in 3D, but it's all just in my imagination. So a lot of the time, I imagine it one way, but in reality, it's not like that at all. The model ends up being a complete nice. Well, I look like a celebrity, don't I? Wearing 2 of these at once, like those people interviewing heads of state. Honestly, back then when I was working with Revit, the section view was, and you just can't get a feel for it. When you cut a section, it's all over the place and you can't tell which line is which. All I need is a 2D section to show the elevation. Architecturally, that's all I need. But I have to draw every single component just to see the section, so the amount of effort increases many times over, and it's incredibly inefficient. Not to mention, at that time, its server system, BIM 360. Honestly, back then it was supposed to be the 4.0 era, but that server felt more like 0.4. So it was absolutely rubbish. Using it just made you feel uneasy all the time. It was really frustrating. Every time you tried to generate a drawing, it would just spin. Then when you opened another file, it would start loading again. It just kept spinning and spinning for ages, and honestly, this period was incredibly stressful with such tight deadlines. With AutoCAD, I could finish the job in 5 minutes, but with this, I could be faffing about for an hour and still not be done. That was the problem with Revit. And then thirdly, the cost. The licensing fees for Revit are also quite high. Now, for the fourth point I'd like to make, this is a particular issue that I have personally noticed that the vast majority of companies using Revit frequently seem to encounter. Because our team also reviews various apartment projects and such, where the Revit system is used for structure, MEP and architecture, all coordinating together. A major issue is the loss of control. In reality, these aren't just minor errors anymore. It's as if people have completely lost control over clashes and various other issues. And they're satisfied as long as they can produce the 2D documentation. So what exactly are these problems? For example, this is one of the projects I've reviewed. When it came to the technical design stage, they didn't have a system in place to coordinate the different disciplines with each other. But if you only use Revit, when you try to combine all the disciplines, the file becomes extremely heavy, and each time you do it, it's incredibly labour intensive. As a result, people get discouraged and only do it once or twice before giving up. So I uploaded it to our system via Trimble Connect to check for clashes on their behalf. Even at the technical design stage, there was still a beam running across the staircase like this, and the clearance was only about 1.3 metres. And there are a lot of issues. When they draw, they mainly just show it in 2D. But as for coordination, it's all just floating around here. The fire protection piping system's everywhere. The ventilation ductwork. The structural beams are above, while the architectural walls are below. The beams stick out above, sloping along with the MEP systems. Basically, why is it out of control? That's because I'm assessing a psychological state. There's something called the broken window effect. It means that when you have a rule for something, but you let it slide, you stop controlling it, and you start seeing it as normal, then after that, it's as if that rule no longer exists. With this project, the issue of coordination seems unnecessary, as if it doesn't exist at all. As a result, there are so many fundamental issues that I see as being out of control when you simply can't manage this system. It seems that when the deadline approaches, they just switch things on and off to submit, exporting the 2D documents just to tick the box. But as for the quality of the design or anything else, it's completely out of control. Following on from that process with the Revit system, it really does make a difference. It didn't live up to expectations and actually became a barrier rather than a tool that could be used according to my working criteria of simplicity and efficiency. So at that point, I moved to a new company, which is Skyline, with the hope of finding a new direction, something different. Based on my own thinking, whatever brings efficiency to the company is what matters. So when I joined the new company, I went back to using the AutoCAD system. I found this was still more effective than using Revit in that way. So going back to AutoCAD, the first thing was the team. At that time, the staff I recruited were all highly experienced and very skilled professionals, each with over a decade of experience. The reasoning was, if you have just 2 or 3 people and they keep making mistakes, it's actually more trouble to fix their errors than to hire someone truly excellent. So when I returned to AutoCAD, I invited a very skilled technician who was also an expert in AutoCAD. That was Mr. Fong, born in 1979, a friend of Mr. Hung here. He was exceptionally talented at building this system. However, the drawbacks of 2D remained just that, drawbacks. Even though we had a high level of expertise and exercised good control, mistakes still happened. And when we got to the construction site, we would still occasionally encounter very basic errors that simply couldn't be detected beforehand. As for deadlines, by that point we were actually managing them better. But let me ask you all, haven't you always felt, after issuing the drawings, that lingering anxiety, not knowing where there might be a mistake or wondering what comments Mr. Chu might be about to make? That's really the issue with 2D documentation. You simply can't control everything 100%. There are bound to be errors. It's an extremely uneasy feeling when releasing those documents. Then the next stage came after we'd been working with the AutoCAD system again for about 2 years or so. At that point, the Ministry of Construction issued a regulation requiring the application of BIM for first-class projects. At that point, AutoCAD was no longer suitable. So we were deliberating, if we were to do BIM, then it would have to be Revit. But we didn't really want to go back to that old way of doing things. At that time, there was also a new direction to consider, as I was also following the SketchUp fan page, and there was a process called VBO. So we weighed up those 2 options. With Revit, it seems that in the market, 99% of investors only know about Revit. Now, if you're doing BIM, do you use Revit or not? People don't mention any other software at all. Revit's market presence is really significant. But I was still determined that I had to find something more efficient. I couldn't just follow Revit. So at that time, I got in touch with Q-On. Let me introduce him here. Q-On was the consultant at that time and also the person As for the company's future trends, at that time Kuong opened up the floor and discussed with the director and me about how CHAP would address the BIM issue and so on. Geometric information, non-geometric information and all that, at the time it all sounded like a muddle to me. I didn't understand a thing. But basically, I realised it could solve the problem and overcome SketchUp's shortcomings in terms of marketability when doing building information modelling. Even if the client doesn't require it, we have to convince them that we can do it. If we can't persuade them, then that's that. If we use the other software, we'd be doomed before even meeting the client. One of the reasons I chose SketchUp for this building information modelling workflow, first and foremost, is the user experience. In fact, you'll notice that anyone, when not forced to use another software, will choose SketchUp when working in 3D. In the Vietnamese market, that's mostly how it is. SketchUp seems to be a tool that anyone can use. It's very familiar and the user experience is exceptionally good. So for us, that's one of the criteria. When staff use software they enjoy and feel comfortable with, only then can they stick with it for the long haul. And the creations, the architectural ideas, they're not constrained. That's the first criterion. The second point is that when applying BIM, it's extremely flexible in the way that you can draw first and assign attributes or components later. That means at the concept stage, you don't need to assign anything yet. You just need to see the layout. So you can draw freely in whatever way suits your workflow or whatever you find convenient. When you reach the stage where you need to add information, you simply select it. If it's a wall, you assign it as a wall. If it's a column, you assign it as a column. It's very natural and extremely easy to apply BIM by attaching components to the model. The third point is that SketchUp performs exceptionally well in 3D and visual representation. You can utilize this software in layout to present three-dimensional architectural diagrams, or for high-quality visualizations, simulations, or even colored floor plans for initial conceptual design documents or sales brochures. SketchUp can handle all of these things, and on our side we hardly ever use Photoshop, we just use SketchUp to present everything directly. So this is one of its advantages. This is the factor that prevents fragmentation, and it's extremely important in a system that you want to control and keep simple. For example, if you use AutoCAD and want to add colour, you'd have to export from AutoCAD to PDF, then import into Photoshop, then add the colour in Photoshop, and that's it. But life isn't that simple. You'll need to make changes. Today you need to tweak something. Later you need to adjust a bit more. So you end up repeating that process again and again, 2 or 3 more times. And when you have to do it so often, the person doing it will definitely get frustrated and annoyed. Sometimes you just want to make a small change, but you don't even dare to ask anymore, thinking, why do I have to keep making these fiddly little changes? And when everything is so fragmented like that, the quality of your design will inevitably go down because of software fragmentation. With SketchUp, however you make your changes, the blend and the face showing the colour and material will update automatically. You make the change at the start and that's it. You don't have to go through all those other steps, just use the one piece of software, SketchUp. That's an example of how to prevent fragmentation. Our aim is for our software to meet that very standard. The fourth point is the potential for integration with other disciplines. At present, both interior design and landscaping use SketchUp for conceptual work. At Skyline in particular, both interior and landscape teams develop their construction documents entirely in SketchUp. From start to finish, everything is based on a single central model shared with the architecture team. This approach ensures a very high level of consistency. Structural and MEP disciplines are also developing strongly on the SketchUp platform with the support of various plugins. Regarding interiors, let me show you a few images. Rolling out interior designs in perspectives and so on is quite standard. These are images of interior layouts created in SketchUp. They are generated from the 3D model. This is landscaping, showcasing various types of floor plans in different styles. Here is the MEP system, including the electrical and plumbing systems. Just showing a few examples here. As for the structure, this is quite a large project with over a dozen blocks. The structural elements are displayed very intuitively. Just by looking, you can immediately tell the dimensions of each column and beam. It's extremely easy to manage. Which areas are sunken slabs or anything else? As for drawing the reinforcement, it's automated, so we no longer have to draw each individual bar. To talk about the workflow, just using SketchUp alone isn't enough. It's only a necessary condition. SketchUp helps us create drawings and attach information and so on, but it also has certain limitations. It can't integrate all information into a single model in the way that true BIM does. It's quite restrictive. In SketchUp, they've added another piece of software for coordination, which is Trimble Connect. So all the architectural models, whether we split files or whatever method we use to draw, are all gathered into this central model. And in this model, we go in and manage everything from design to coordination between disciplines, clashes, or anything else, all within this model. This is the 500-bed hospital project carried out by Skyline. It includes all disciplines: architecture, structure, interior design, landscaping, and exterior lighting. When everything's displayed on this single model, we can assemble all the files together so we can turn things on or off or observe whatever we want. Here, we can check whether the space we want is correct and whether there are any issues. We'll control everything from there. It seems that we no longer have to go through each 2D drawing to see what the design is like. Instead, we can directly check the design spaces in 3D. Regarding the ideas and the dimensions, for example, here I want to check the staircase or something like that. And here I want to check this staircase to see how it has been designed. This Trimble Connect is extremely lightweight. It might look a bit unattractive, but it is very light indeed. Because, for instance, you can use your phone when you go to the construction site. You can use your phone to open it up, pull up the sections to check whether the dimensions at that spot are correct or not, and just by looking you can see what's extra and what's missing. For example, on the model, it's quite intuitive. So Trimble Connect is an environment where you can manage the design aspect and check for clashes on that model either manually or automatically, as it has tools for both. Now, the third piece of software that I want to introduce is something indispensable in this workflow. This one leans more towards digital transformation, so to speak. As it happened, the company also came across this software and found it quite suitable. Afterwards, when combined with SketchUp, they complement each other and it's extremely effective. With the information system uploaded onto this platform, it covers everything from the very start of the project. Right up until completion, all the information is linked together and every detail is controlled, so we can transfer it over to SketchUp with accurate data and work progress. Plus, we can interact online with other parties, including the investor. All done online, so there's no need to send files back and forth. It will save the history. With LAC, there are loads of features all bundled into one piece of software, rather than having separate, disjointed programs. We can interact, link up, and connect with each other on all these matters. So, I wonder, for all of you, when it comes to managing big projects these days, what software are you using? Or are you still using Xalo to chat and exchange information, then jotting things down, making meeting minutes and saving them in Word, then this and that, entering data into Excel and so on? This is what we call fragmentation. These things are called fragmentation because they're not linked together. Word and Excel, for example, there's nothing connecting them at all. Then you have all the Google apps like Google Docs and so on, which do allow you to interact online. You can edit online at the same time, but the level of interaction is extremely poor because it lacks something like LAC, which is this messenger feature. This is the core, the center. Only by operating on this can you interact with all the other software. To illustrate this, let me give you a quick example. One example I've applied is the statistics for finishing materials. For a project with several hundred or even 1,000 rooms, I'll export the data from Excel, identifying what each item is, like what the code is, what the function is. As for information such as walls, ceilings, floors, elevations and everything else, I'll handle all of that on this LAC sheet. And with this, I just follow the initial design brief from the client in a very general way. They don't give us hundreds of rooms at once to input. They provide it in a very general manner. For example, specifying which area uses what materials. So our team will tick and select those materials here, and then they'll leave comments. They'll come in here and comment on the right-hand side. So they leave comments on the right, and our team interacts with them through these comments. For example, they might say, that should actually be a different material. Based on their comment, we'll tick and select the material again according to the client's suggestion. It's very quick. We don't have to draw up a plan, send it over, and then have them read it. That process is very cumbersome. For example, with finishing materials, we usually display a code on the material, like on this floor here, VK0 something. This code will link to an image explaining what type of wooden flooring it is. If we send this to the client, they'll read the code, then have to look up the chart. It's very time consuming. Doing that for hundreds of rooms takes up quite a lot of time. With this system, we only need to use this table. And this table is also used for cost estimation as well as by the construction contractor. All information is unified on this single table. Which room, what the walls are like, the ceiling, the floor, the heights, everything. This is like a digital system to support the drawings. We shouldn't try to cram all the information into the drawings themselves. Now, one of the applications for managing information, these are the input details. So it will be part of a project process. If anything changes, it's like a logbook recorded by date. But if you do it by date, one day there's a door, another day there's also a door, and you won't know which information is the latest, nor how to find it. So we'll link it horizontally with the design service system. For example, all the information about a window will be kept here. What's the purpose of this? So that when we assign tasks, for example, if 3 people are drawing 3 different floors and all of them are drawing windows, they can all come here, read this information and carry out the work. It's not necessary for one person to specialize in windows. That person can do any task at all, because the system we've built allows everyone to access the information, and the most up-to-date information is always displayed at the top. Any outdated information is crossed out, so we can keep track of the history and see how things were before. And it will be linked to the design process and the project's logbook. And all the evidence is kept, including how the investor reported things. This avoids using Zalo, where when you need that information, like when something was confirmed or what the details were, you end up searching for keywords, and sometimes you find it, sometimes you don't, and sometimes the image is gone altogether. These projects often drag on, some last for years, so information on Zalo tends to be lost completely. Therefore, all information must be kept. Any evidence or documentation needs to be saved. So how do you combine such information with SketchUp? For example, drawing a door. Then I'll create a door library here. Combine it with the 5D library plugin. So the person drawing the door will go into the... Sometimes when you place a door, all its parameters are already available. Someone will set this up according to the input requirements. So a library will be created. For example, for the doors in the auxiliary building, there are only so many doors. When you come across a 2D door there, you just take the 3D door and place it into the 2D drawing. There's no information attached, it's just a single or double leaf door. But for each of those doors, the corresponding 3D door has already been set up in this library. All you need to do is insert the 3D model into the correct 2D position. When you select these 3D doors, the schedule will be generated automatically. No need to enter any additional information at all. The schedule will depend on the dimensions, and you can adjust the size of each door according to its position. Here is a table for coordinating the different disciplines and information with each other. If we use Zalo or other chat applications, the information shared can easily get lost. Once it's lost, you can't remember when it was discussed or what the response was. Here, everything is saved as separate items, each with a status showing whether it's been resolved or not, making things extremely clear. And whichever discipline's involved, you can filter by that discipline to see exactly what issues remain for you. So in a project like this, all information must be completely clear. So this is for the in-out section. I'll also show an example from the 500-bed hospital project. Let's say we filter by legal procedures. You'll see that from the initial approval to the construction permit, it takes about 4 months. That's the 500-bed hospital project with a 4-month timeline, including the wait for legal procedures. This demonstrates just how efficient the system is. Honestly, for a project like this, if you were to use Revit or AutoCAD the way I've experienced before, it would be absolutely unimaginable. So how does it help us control the design? For example, here's the land area, and on the right there's a comment section to save the entire history. For instance, what was the initial land area provided by the investor? Then, if there's a comment about what has changed, there will be a link leading to the project's progress, the project log explaining why the change was made. After that, if anything else changes, it's entered in the next section. So just by clicking on a land area, you can see its entire history, what it's been through, what's changed and why. That's to keep track of the various parameters. These parameters are no longer just figures you have to imagine. There's a reason behind why things are done that way. And when you click on a particular figure, you'll see the area measurement image right there. So the person in charge can click on it, check, and know whether it's correct or if there's been a mistake in the measurement. But if you just hand over a 2D drawing like this, there's no way to keep things under control. Exactly. The areas where the coefficient isn't applied are also very clear when you look at them. Then when it comes to editing the drawing and leaving comments and so on, how do we manage that? For example, here I have some illustrations for the content that's been amended. For instance, this symbol here is incorrect. So after you've made the correction, you'll take a photo and paste it into the after correction column. That's it. And whoever carries out the task will tick this box here. So the person in charge just needs to click on the illustration of the image that needs correcting, and then click on the image showing the result. That way you can see how it's been amended and whether the correction is correct or not, and that's it. Normally, people will leave comments on the PDF and assign the corrections to the staff team. Once the corrections are done, the person in charge opens that PDF, opens the PDF with the comments on one side, and then starts looking back and forth, back and forth. It's extremely time consuming and mistakes are bound to happen. So that's where I'll apply this LUT for things that are interconnected, all linked together within a single system. This LUT is a second anti-fragmentation system running in parallel with SketchUp. So the point is, with these two systems, I can sync certain things between them, so they're connected to each other. Besides that, I also use this LUT for the training system. Everything that's already been covered in training is stored there. And when new staff join, they can come in and read it. So I don't have to waste time repeating things I've already explained. There are also instructions available. If there's anything I haven't explained yet, I'll explain it, and then the person who's been instructed will know. Then they'll write up the instructions here, and I'll check whether what they've written is correct. By writing it down, they pay more attention, and their ability to absorb the information becomes more serious and accurate. This way, we can build a system of instructions or design topics, so we're not just sitting around chatting, saying things like, hey, when you design a swimming pool, it should be like this or that. Everything has to be made absolutely clear. This isn't a process as such, but it's a set of guidelines, and if needed, there will be instructions to follow. So how do we ensure that all the staff share the same basis for implementation, rather than just thinking, I see it this way, or I feel like that, or anything like that? On this basis, we can discuss and interact with each other, but this foundation is the main thing for us to control whether our design is consistent or not. In a business with many years of experience, this system will develop and become more and more complete. If we just pass things on verbally or keep them in our heads, then when a key staff member leaves, all of that knowledge goes with them and the company is left with nothing. We have to recruit new people who bring in a completely new mindset. These are the things that, for a large project or a company aiming for long-term development, Skyline is building things like that. Generally speaking, when it comes to LAC, there are still quite a lot of things, but within the scope here, I'll just introduce a few basic and effective ones. So after about 2 years of working with SketchUp, we've carried out the following projects entirely using SketchUp from start to finish. The first is a hospital project. This is a 500-bed hospital in Thuy Nguyen, Haiphong. Regarding this particular project, as I've previously mentioned, the timeline, including all legal procedures from initial approval to construction permit, was about 4 months. Within that, the period from basic design to technical design was just 20 days. Honestly, for a hospital project, having only 20 days from basic design to technical design is, in my opinion, it almost seems unreal. At that time, there was a situation like this. I was actually on leave and attending meetings online via phone, so while I was out and about, I wasn't fully aware of the timeline set by the investor. I heard the structural team say 30 days was fine, so I thought, all right, 30 days is something we could probably manage. Then when I looked at the schedule again, it was almost time for the TET holiday. The TET break would take about 10 or 12 days. So the actual time to carry out this project from basic design to technical design was only about 20 days. And Skyline had just about 3 staff members. And during those 20 days, we didn't do any overtime at all, yet still submitted everything on schedule. Now, this is a second project related to hospitals. This one is also at the concept stage, a hospital in Haijiong with 1,500 beds. Skyline entered both of these projects into competitions and won awards. Moving on to residential projects. This is also a high-rise project, 40 stories, also entered into a competition. And at the moment, we're finalising the concept. This is another project with 3 blocks, also residential, 21 stories each. As for office buildings, there's currently a 25-story office project in Haiphong as well. I'm so sorry. Please just give me a moment to have a quick sip of water. Right, to give you a clearer idea of the final outputs, firstly, when presenting the concept, what can be achieved? With Skyline, when working on large projects, we don't focus too much on the details, just on what's necessary to properly convey the key aspects for concept approval. These presentation sections are pre-concepts, all integrated directly within SketchUp. You just enter your location and it will analyse the climate and so on, suggesting what should or shouldn't be done. It will propose solutions for the facade, such as how much glass to use, whether to install sun-shading louvers or other options. All of this analysis is done within the pre-concept stage. Once you've drawn it in SketchUp, you've got your file ready. For the overall schemes, usually for each apartment project, our team prepares around 10 or more master plans to consider all the pros and cons. Perspective renderings are already quite familiar to us. As for the layout, it's all done entirely in 2D, nothing in 3D at all. We use faces and add colours to them. When analysing movement and static diagrams and so on, it's all done with these faces. It's better than CAD because you don't have to keep exporting and importing files for the different floor layouts. For example, with the units here, you can separate them to see which ones are 2-bedroom or 3-bedroom flats. That's just the way SketchUp displays styles. At this point, if I switch to a different style and display by material, it looks like this. Still on the same face, I haven't drawn anything extra. I just assign a colour to the tag and the material so I can show a lot of different styles. This is extremely basic in SketchUp and doesn't require much. The units and calculations are done on the LUT. And the slides are also LUT slides without using any additional software, Office Suite or anything else. Then comes the technical design documentation and construction design. With just one SketchUp file, I can have many things. These are also different styles, and I assign materials and tags to them. So we'll have the different floor plans. Firstly, the architectural floor plan, then the ceiling plan, and the finished floor plan. At the technical design stage, it's in 3D, whereas in the earlier stages, we only use 2D. So it's very flexible for our design work. Whenever we need something, it delivers just that. There's no need to be constrained by any extra procedures. Here is the door positioning. Once you finish drawing, you immediately have the door schedule. No need to create any tables or input numbers manually. Developing details, for example, stair details, for instance. Everything is on a unified model. Combined with the structural model are these concrete parts here. That's the structural model, which I didn't draw myself. It ensures the accuracy of the structure as it actually is, so the architecture matches up perfectly. There's no longer the issue of these two disciplines clashing on site. And for this structure, we use SketchUp rather than Revit. Now, regarding the coordination part, as I mentioned earlier about Trimble Connect, there are quite a lot of things involved here, so I'll just touch on it briefly. Hang, you covered that part earlier, didn't you? All right, well, we can sort out any exchanges about that later. As for the final part, which is how SketchUp exports the drawings, with SketchUp's default tool, we can only export it in one way. It's very difficult for different disciplines to interact with each other, and especially with large projects, the contractor will need to produce shop drawings. If your exported drawing only has one layer like that, how can you create shop drawings? Here, with the support of the 5D tool from Kwong's team, export into AutoCAD is done very methodically and layers can be separated. Furthermore, these specific hatches will also be converted directly into hatch patterns within the CAD software. When you take a closer look at the final result, it is also exceptionally neat and well organised, with nothing messy about it at all. And for this project, we also exported this for the contractor to use for shop drawings, and there were no issues with this at all. That's how we communicate with the other parties. Perhaps I'll go back and talk a bit about Trimble there. With coordination on Trimble Connect, In fact, in this environment, you can upload your Revit files directly. And SketchUp files can be uploaded directly as well. So those two models can still coordinate with each other. That means Trimble Connect now supports quite a lot of common file formats already. If there's no supported file format, then all BIM software can export to IFC, even SketchUp. IFC is a universal standard, a common standard that the Ministry of Construction also requires for BIM submissions. You have to submit IFC, not Revit or any other format. So you can think of IFC as being like English. So Revit is like Thai and SketchUp is like Lao. If those two want to talk to each other but can't understand one another, then just speak English. The English environment is like the IFC format that's currently regulated. It's an international standard, and SketchUp also follows the format and the latest IFC regulations, which is IFC 4. And with the workflow and the orientation towards digital design, our current team of personnel is about 25% management level, while the remaining 75% are staff involved in design and related tasks. And there's a notable point, this 75% compared to the days when we worked with AutoCAD and had to recruit people with over 10 years of experience. Now this 75% only have 1 to 2 years of experience. Why is that the case? It means that now we're not under pressure to have staff who must know certain software or be proficient in particular programs. As long as they have expertise and potential for development, they can join this system. Because training in SketchUp with this workflow is extremely straightforward. And after just about a month, people can already carry out around 80% of the related tasks already. Although Revit staff often already have a lot of existing skills. But as for SketchUp staff, I believe that even those who don't know SketchUp can still use it. Because at the company, there's even a girl who didn't know anything about SketchUp at all. She's currently in this 25% group, the management level, but even though she's in management, she still works directly. So after a month of getting to grips with SketchUp, everything was fine. And now she's basically a pro. I'd say that at Skyline, the team is quite small, about 4 people plus myself, so just 5 in total. But the volume of projects is extremely high, whether it's concept work, interiors, landscaping, lighting, everything. So I reckon that with this system, you only need a team that's less than 50% the size of a typical one to be effective. One of the reasons for achieving such efficiency and being able to meet tight deadlines is this. In other companies, typically 1 or 2 people will handle 2 or 3 projects each, so these 2 people are in charge of several projects. The drawback of that is those 2 only know about those particular projects. Firstly, in terms of information, they don't get to access many projects to learn from and only know a very limited number of projects, so their professional development is restricted. Secondly, when a project becomes urgent, these people don't seem to have enough information to work together and push things forward. As for Skyline, with any project, all staff involved at any stage or in any role have access to the information they need to carry out their work. That's exactly the flexibility in optimizing both the system and the personnel. Currently, Skyline is working on around 11 projects. Some projects are at the concept and basic design stage, while others have completed construction design and author supervision. At present, there are only 4 staff members, plus myself, making 5 in total. 3, is that right, Kat? There's also an intern. So with 3 of us and an intern, what is the core value that this brings? Firstly, our creative work isn't constrained or restricted. We can channel all our energy into the creative process itself, rather than having to fix tools, correct errors, or serve the tools. Secondly, the user experience is smooth. When people have a good experience, they feel comfortable throughout the working day, and that's what enables them to go the distance. Then thirdly, there's the value to the business. The business is constantly improving product quality, enhancing its reputation, shortening implementation times, and significantly reducing system costs. We'll also be able to manage project risks effectively. At this point, for me, it's a bit like having a date with your beloved. And to wrap things up, what I want to say is, everyone should start from the experience. The direction we want should come from our professional knowledge, so that we can go back and choose the software, the system, and the way of working that meets our needs. We shouldn't start with a popular tool or something just because it's common, then see what it can do for us and try to adapt ourselves to it. Thank you very much, everyone.